Hi guys, very good morning. Welcome to the session. Myself Dinesh. So today's session is the fourth session on Laplace transforms that I'm taking in this week. So in the last three classes we have talked about, in the first class we've talked about region of convergence, and in the second class we've talked about basic important signals Laplace transforms, and in the third class we've talked about shifting properties. Along with those properties, I've also discussed time reversal property and also linearity property. So the agenda of today's session is differentiation properties. Not only differentiation properties, I'll be discussing about integration properties as well. So if I put differentiation and integration both, then the heading will look very big. So that's why I've reduced it to only differentiation properties. But I'll be discussing differentiation and integration properties as well. Along with that, I'll take some questions based on linearity property as well. The reason is there are a few things I want to make you understand regarding linearity property. So once we have to do some problems based on linearity property, so that we'll become comfortable when we are solving problems based on differentiation and other things as well. So there are a few links that I have not covered, so which I want to cover in today's session. Okay. Hi Chandrasekhar, good morning. Right. So this is my profile. So this is my Telegram group. If you wish to ask me any doubts based on communication systems or signals and systems, you can post it in this group. Okay. Right. So what is the agenda of today's session? So in today's session, we're going to talk about differentiation properties, integration properties, and also some problems based on Laplace transform. The first thing that I'll be doing is whatever homework questions I've given in yesterday's session, first I'll talk about them. I'll discuss the solutions for them. Okay, and then we'll talk about differentiation and integration properties, okay, and some problems based on linearity property as well. At the end, I'll be giving you some homework questions as well. Okay, so listen to the class carefully. We're going to learn a lot of new things in today's session. So I want your perfect focus for the next 1 hour. Right. So let's quickly discuss these homework questions. So this question is based on time shifting property, right? So whatever is inside the step function, whatever is argument inside the step function, that is important for us. We can't modify this. So outside functions, whatever is the function that is neighboring to the step function, those functions we have to adjust according to the argument of step function. Okay. See here, if you're seeing t minus 2, you have to make sure that there is t minus 2 here. So then only we can apply time shifting property and find the Laplace transform. So let's see the basic signal inside this signal for which we know the Laplace transform of. Okay. So what is the basic signal that you can see here? E power minus at into u of t kind of signal. So here it is e power minus 2t into u of t signal. For this signal, it's very easy for us to find the Laplace transform. Okay. Inside this function, remove unnecessary shiftings and all the unnecessary stuff. Write the very basic form of the signal without any shifting, without any modifications, so that we know the Laplace transform of this one. We can find the Laplace transform of this one very easily. So for this one, it's very easy for us to find the Laplace transform. What is the pole? Anyone can say here, what is the pole? What is the pole here? Anyone? Anyone? It's very easy to recognize the pole. When you see exponential signals, it's very easy to recognize the pole. What is the pole here? Minus 2 is the pole. In the power, remove the time variable time, and remaining part is the pole. In the power, whatever constant you are seeing, that itself is the pole. So minus 2 is the pole. And what is the Laplace transform? It is 1 by s minus of pole, or 1 by s minus of minus 2 is s plus 2. Okay. It's not 2, it's minus 2, Arvind. Okay. Hi Rahul, hi Arvind. Chandrasekhar, 7 months is also sufficient, but the point is amount of effort that is required based on your capabilities is same. But if 7 months is available, if you can put more time per day, then it is definitely possible to crack GATE in 7 months also, even in 5 months also. But you have to increase the number of hours that you are spending. Okay. Generally, people who start before 1 year, they spend 5 to 6 hours a day. So since you are starting late, you spend 8 hours to 10 hours. But if you feel you are an average student, you have to spend more time if you are serious about cracking it. Okay, fine then. So what is the ROC for this? ROC is real part of S greater than real part of the pole, which is -2. This is the basic signal that we know. So in this, let's apply time shifting property. So if you apply time shifting property, I am replacing t with -2. For this one, we can find the Laplace transform easily with the help of time shifting property. It is e power -2s divided by s plus 2. Okay, is there any new pole created here? The poles that are here are -2 is already the pole. Because of this -2s, if in place of s, if you substitute -infinity, we have a problem here. The new pole that is created here is -infinity is a new pole. So is -infinity part of this ROC? Because poles should not be part of the ROC. This -infinity is not part of the old ROC. So that's why there is no change. We don't need to change the ROC. If this new pole created, if it is part of the ROC, then we should exclude this. We have to remove this from the ROC and write the ROC. So the ROC is no change in the ROC. Real part of S greater than -2. ROC should never include the poles. The poles here are -2 and -infinity. They are not included in this ROC. Okay, wonderful. But this is not the signal that we are interested in. We are interested in some modified signal. So here we need modification. Let's do that modification here. So let's rewrite this one. E power -2t plus 4 is what we have here into u of t minus 2. But what we want is plus 3. So if you want plus 3, let's write it as e power -2 to plus 3 plus 1 into u of t minus 2. Get the Laplace transform, whatever is the closest signal that you can get for the given question, and then adjust it. Okay, we want only this part. So e power 1 we don't want. So for this we know the Laplace transform. E power -2s divided by s plus 2. ROC is sigma greater than -2. Okay, now we don't want this one. So let's divide with e power 1 on both sides. So that we get what we want here in the time domain. So let's divide with e power 1 on both sides of Laplace transform. You know, according to linearity property, whatever constant you multiply in time domain, same constant will be multiplied in Laplace also. So you just divide with e power 1 on both sides. So it will become divide with e power 1, or you can also say that multiply with e power -1. So multiplication with a constant will not change the ROC, we know that. So that is the answer. I am multiplying with e power -1 both sides, or dividing with e power 1 both sides, you can say. So we got the exact signal that they are asking, and this is the Laplace transform. If the options does not match this, okay, try to make some modifications to this. Maybe they might have written this numerator as e power minus of 2s plus 1, something like that. They might have combined these two. Okay. Right, that's it. We're done with the first question. Let's quickly do the second question also. Can you try it out? The second question. Anyone can quickly answer the second question? The first step to do is whatever is the basic signal that you know, write that first. E power 5t into u of t is the basic signal that I have in mind. The Laplace transform of this one is, what is the pole here? Can you recognize the pole here? Whatever is in the power, whatever constant is there in the power, that is the pole. Okay, whatever constant is there in the power of exponential signal, that itself is the pole. 5 is the pole. So our Laplace transform is for this basic signal e power at into u of t kind of signal. Our Laplace transform is 1 by s minus of pole. What is the pole? 5. And ROC is real part of s greater than real part of the pole. Real part of 5 is only 5, because there is no imaginary part in this. The pole itself is real. So that is the ROC. ROC is not including the pole. Mind this, pole is at 5 and ROC is not including 5. Okay. Right, now let's do some adjustments so that we get this signal. So we don't want u of t, we want u of minus t, right? We want u of minus t. So if you want u of minus t, so you can't just replace u of t with u of minus t, right? We have to apply time reversal property. So if you want to apply time reversal property, everywhere t is replaced with minus t. So that's why let us take e power minus 5t. so that it will become s plus 5 and this will become minus 5. Pole becomes minus 5. I hope you are understanding why I'm taking minus 5 instead of plus 5, because we have to apply time reversal property because there is u of minus t. If you want to apply time reversal property, everywhere t is replaced with minus t, then you should be getting u power 5t here. So that's why I'm taking e power minus 5t. So now let's replace t with minus t. If you replace t with minus t, this becomes e power 5t into u of minus t. Observe carefully. I've taken this signal. Why I've taken instead of e power 5t, e power minus 5t? The reason is we have to apply time reversal property. When you apply time reversal property, e power minus 5t becomes e power plus 5t. Finally, we want e power plus 5t, right? So that's why here I've taken e power minus 5t. Right. Next. So what is the for Laplace transform of this one? So when you're applying time reversal property, when t is replaced with minus t in time domain, what happens in Laplace? S is replaced with minus s everywhere, including the ROC. Here also real part of s is replaced with s with minus s greater than minus 5. Right? So this becomes minus 1 by s minus 5. Minus sign, if you send it on to the other side, the inequality sign changes. Minus will get cancelled. It becomes real part of s less than 5. So what do we want here? If we don't want e power 5t, we want e power 5t plus 6. So what we will do is, we want 5t plus 6. So that's why let's add plus 6 and subtract minus 6 so that we are not modifying the signal. So if you do plus 6 and minus 6, this signal is same as this signal, and hence for this signal same Laplace transform. Now we want only 5t plus 6. So let's remove this minus 6. So what we will do is, we will multiply with e power plus 6 on both sides. If you multiply with e power 6 on both sides, this 6 e power minus 6 will go off because we are multiplying with e power plus 6 on both sides. This part and this part gets cancelled. Now Laplace transform becomes minus e power 6 divided by s minus 5. ROC will not change because of multiplication with a constant. Okay. Very good. I hope it is clear till this point. Next one. How about the next one? So what is the basic signal that you can think of? The basic signal. So there are cos signal is also there, exponential signal is also there. So first you can take only the cos part and then apply S shifting property. When you multiply with an exponential signal, what happens in Laplace? S shifting happens. We have discussed that property in yesterday's session, right? So if you recollect the formula of cos AT into u of t, Laplace transform S divided by s square plus a square. ROC is real part of s greater than real part of the poles. There are poles here. What are the poles here? JA and minus JA are the poles. Real part of them is 0. So ROC is sigma greater than 0, or real part of s greater than 0. Now let's apply time reversal property because they are using minus u of minus t here. So let's apply time reversal property, and instead of here I'll substitute 6 also. Replace t with minus t. If you replace t with minus t, cos of minus 60 will become cos 60 only. Replace everywhere t with minus t. So cos of a into minus t is cos at only. In Laplace, s is replaced with minus s divided by minus s whole square is s square only, plus a square is 6 square. So real part of s is replaced with minus s. Mind this, the reason why we write it as, whenever we are applying properties, we write ROC as real part of s greater than 0 or less than 0, something like that. The reason is, we have to replace s with minus s when you are applying time reversal property. So if you don't see s, you will not feel like substituting minus s there. Okay, so understand that there is real part of s here. S is replaced with minus s. So what happens to the ROC? ROC gets inverted. Sigma less than 0. Observe this one. Whenever u of t is there, ROC will be like sigma greater than real part of the pole. Whenever there is u of minus t, ROC will be sigma less than the pole. For left-sided signals like this, ROC will be left-sided. For right-sided signals like this, ROC will be right-sided. Simple stuff. Okay, right. ROC for right-sided signals is right side of the pole. For ROC for left-sided signals is left side of the pole. Okay, right. So we got the Laplace transform of this one. Now let's apply S shifting property. It looks complicated, but it's an easy question if we apply the properties. E power minus 5t cos 6t into u of minus t. Laplace transform S. Whenever you multiply with exponential signal, on the other side what happens? S is replaced with S plus 5. Because in S shifting property, the sign here, sign in the exponential part and in the Laplace are exactly opposite. Whereas in time shifting property, the sign will be same. If it is minus 5 here, there it should be S plus 5. So replace everywhere S with S plus 5. S plus 5 divided by S plus 5 whole square plus 6 is 36. Will the ROC change? Definitely it will change. So this, imagine, because of space constraint, I'm writing it as sigma, but basically if it is better to write it as real part of S. Instead of real part of S less than 0, we have to write it as real part of S plus 5, real part of S plus 5 less than 0. So the ROC will be a real part of S plus 5 less than 0, which means ROC will be real part of S less than minus 5. Okay, real part of S less than minus 5. Very good, Rahul. But you did not tell me the ROC. If you had told me the ROC, the answer would have been perfect. But anyway, I assume that you know the ROC part. Okay, so I hope this question is clear. So now can anyone tell me what are the poles here? Can anyone tell me what are the poles? What are the poles of this signal? Anyone? E power minus 5t means minus 5 is pole. If only e power minus 5t into u of minus t is there. But cos 6t is also there. Because of cos 6t, the poles are plus j6 and minus j6. Because of e power minus 5t, minus 5 is the pole. Combination of these two. You can imagine cos 6t as e power j6t plus e power minus j6t. So if you multiply with e power minus 5t, it becomes e power minus 5 plus j6 into t plus e power minus 5 minus j6 into t. So just expand this as e power jx plus e power minus jx divided by 2 and combine these two. Then you'll observe the poles very easily. So the poles are minus 5 is the real part of the pole, plus j6 is another pole, plus j6. This total thing is one pole. Another pole is minus 5 minus j6. So when cos and exponential signal together are there, you have to observe carefully to find the poles. Okay. When a simple exponential signal is there, it's easy to find the poles. But when combination of cos is there, you have to observe carefully. You have to combine them together to understand the poles. Or in Laplace also you can see. Obviously, when you see Laplace transform, you can find the poles very easily. What are the poles here? So equate the denominator to 0. Equate the denominator to 0 and find the roots of it. Equate the denominator to 0, then you'll find the roots. Roots are minus 5 plus or minus j6. And what are the zeros of this one? There is only one 0 for this Laplace transform. What is that? Anyone? Is there any chance? Is there any value of s for which this Laplace transform becomes 0? Minus 5. When you put s equal to minus 5, the Laplace transform becomes 0. Right? Right, very good. So shall we move on to the next question? Let's move on to the next question. Next is a very interesting question. Yesterday we have done wonderful questions based on this model. So, okay, let's try this one. Yesterday we have done with cos part here. Instead of sine, we have done it with cos. Okay, right. Okay, so x of t has these poles. X of t has poles as 4, 5, 8 and 10. How about e power 4t into x of t? When you multiply a signal with e power 4t, what happens? S shifting property. X of the Laplace transform of this one is x of s. Okay, what is the Laplace transform of this total thing? I'm considering only till this point. Till this point. E power 4t into x of t, Laplace transform is x of s minus 4. Sign is opposite. If it is plus sign here, it is minus sign here. X of s minus 4. S shifting property we are applying. So here s is 4, 5, 8, 10. So for this total signal, s is replaced with s minus 4. S minus 4 is 4, 5, 8, 10. Okay. So s will become, the poles will become 4 plus 4 is 8, 9, 12, and 14. These are the poles. Now, for this total signal, what happens? For this total signal, what happens? Sine 60, you can think of it as, so this total part has a Laplace transform of x of s minus 4. For sine 60, what is the Laplace? Sine 60 is multiplied. What is the Laplace transform? Sine 60, you can just write it as e power j60 plus e power minus j60 divided by 2 into divided by 20 power 4t into x of t. Okay, so which is equal to so this total signal, we know the Laplace transform already. If it is multiplied with e power j60, you can apply the s shifting property for this part and this part also. Okay, let's do this. E power j60 into e power 4t into x of t plus e power minus j60 into e power 4t into x of t. There are different ways in which you can do this problem. I'm showing you only one way. If you get a different idea, you can do that. Okay, right. So for this part, we know the poles already. When you multiply with e power j60, what happens to the poles? The Laplace transform of this one is 1 by 2 into x of s minus 4 is already the Laplace transform for this part. And because of j60, it becomes s minus 4 minus j6. And how about the Laplace transform of this part? It becomes half into x of s minus 4 plus j6. Okay, instead of finding the Laplace transform of only this part, you could have expanded sine 60. My mistake here. It's a small mistake I made here. Small mistake here. Minus sign here. Okay. Sign, right? So it should be a minus sign. And in the denominator, it is 2j. Okay, so instead of finding the Laplace transform of only this part, you could have expanded sine 60 like this. And for this total signal, see this one? This part is e power 4 plus j6 into t. 4 plus j6 into t. For this one, it is 4 minus j6 into t. So directly, you could have found the Laplace transform of this part as x of s minus 4 plus j6, x of s minus of 4 plus j6. This one becomes x of s minus of 4 minus j6, something like that. So tell me, what are the poles of this one and poles of this one? Simple stuff. What are the poles for this one? S minus of 4 plus j6 or s minus 4 minus j6. See, already we know the poles for this one. Because of sine 60, what happens? j6 is multiplied, e power j60 is multiplied. Because of that, what happens? S is replaced with s minus j6. So the new poles will be same poles with an imaginary part extra. 8 minus j6, 9 minus j6, 12 minus j6, and 14 minus j6. See this? Simple stuff. Same poles. Because of e power j60, all the poles are getting added with j6. Okay. So what are the poles of the next part? The next part is because of the second term, e power minus j6. So minus j6 is the extra contribution to the poles. Okay, or s is replaced with s plus j6. S plus j6 equal to 8, 9, 12, 14. So it becomes 8 plus j6. So for this, I think it's not minus, it will be plus here. Because e power j60, when you find the Laplace transform, it becomes x of s minus j6. So s minus j6 is replaced with s minus j6, 8, 9, 12, 14. S will become 8 plus, 9 plus, 12 plus, and 14 plus. And for the other part, for the second part, it will be just opposite. 8 minus j6, 9 minus j6, 12 minus j6, 14 minus j6. Okay. In yesterday's session, I have done it in a much simpler way. Here I've tried to do it in a different way, but that has taken a little bit more time. Instead of finding the Laplace transform of this part and finding the poles of this, find the total thing together. if you remember yesterday how I have done, that is much better way. So first it's better to write this as e power 4 plus j6 into t minus e power 4 minus j6 into t divided by 2 into x of t. This is much better way. Sin 60 I'm expanding like this. So if you multiply these two terms, you'll get like this, something like this. So there are two terms here, x of t multiplied with this and x of t multiplied with this. Here, yes, denominator will not affect the answer because I'm just asking the poles only. I'm not asking the Laplace transform. So definitely in the answer Laplace transform, a constant is multiplied in time domain. That constant will be there in Laplace also. But here I'm talking about only the poles part, right? So the constants will not affect the poles. Constants will not affect the poles. Okay. So the first part has the poles of, first part has a Laplace transform of half into x of, see this one, s shifting property, s minus 4 minus j6. The second part has a Laplace transform of half of x of s minus 4 plus j6, something like that. Now you can find the poles for this. If you know the poles of x of s, you can find the poles of this one. Okay. So I've explored a different way of doing it. Sometimes when some procedures might be taking more time than the other procedures. But trying is good. Because when you try different procedures, you learn new things. Okay. So let's move on to the next question. So try to practice this one. Whichever question you are finding it difficulty, try to practice it once again. Okay, do it in your own way. With whatever knowledge you have, try to do it in your own way. Then you'll get confidence. Alright, so let's come back to differentiation properties of Laplace transform. So we're done with homework questions. So homework questions are taking a lot of time. Okay, so let's talk about differentiation properties. If x of t has a Laplace transform of x of s, let's say the ROC is R. Now, if you differentiate in time domain, this is the easiest property that you can remember. If you differentiate in time domain, what happens in Laplace? It is multiplied with s. It is multiplied with s. Will the ROC change? So that is slightly tricky to say, but mostly ROC, most of the time, 99% of the cases, mostly does not change. When it changes is, I'll tell you some scenarios. Except in those scenarios, one or two scenarios, generally it will not change. Okay, I'll explain those scenarios. Okay, so I'll talk about the other differentiation property as well. So differentiation in time we are talking. So we can talk about the other differentiation property which happens in Laplace. See this one, differentiation in one domain. What is happening in the other domain? Multiplication with the variable. In the Laplace, variable is s. Differentiation in one domain, multiplication with variable is happening in the other domain. Same stuff. Multiplication variable in time domain. In time domain, the variable is t. If the signal is multiplied with the variable in that domain, what happens in the other domain? Same stuff. See this one? Multiplication with variable in one domain, differentiation in the other domain, right? Same stuff here also. So if you do multiplication with variable in time domain, t is multiplied, then what happens in the other domain is d by ds of x of s. Differentiation is happening, but there is an extra minus sign. There is an extra minus sign. I'm writing both differentiation properties in one place so that it will be easy to remember. For a differentiation in time, there is no negative sign, but differentiation in Laplace, there is an extra minus sign. Okay. Both are not exactly dual of each other. There is an extra minus sign in one differentiation property. Mind this. Okay. So in this case, it does not change. It never changes. The ROC does not change at all when you're talking about differentiation in Laplace property. Because when you differentiate, what happens? The denominator order increases. So for example, 1 by s plus a. If you integrate it, if you differentiate it, it becomes minus 1 by s minus 2 whole square or s plus a whole square. For example, Laplace transform is 1 by s plus a if you differentiate it, it becomes minus 1 by s plus a whole square. Is the pole distribution changed? Earlier the pole was minus a. Now also the pole is minus a, but there is a double pole at minus a. Okay, when the pole, when the location of the poles does not change, ROC does not change. Because the only point that we need to mind is ROC should not include poles. Whatever pole is there earlier, same pole, but there is double pole. If there is double pole or single pole, it's the same thing. ROC should not include it. That's the only point. Right? Because of differentiation, what happens? The order of denominator is increasing, the order of the poles is increasing, but that does not change the ROC. In differentiation, when you talk about differentiation in time property also, most of the cases, it does not change. You can also remember it does not change. There are only 1 or 2 special cases. We can talk about that. Okay. Okay. Let's take some examples to understand better. A signal x of t has a Laplace transform x of s is equal to 1 by s into s minus 1, where ROC is a real part of s greater than 0. Find, I'm taking a case here, which is a special case where the ROC changes. Let's find the solution for this. X of t has a Laplace transform x of s, which is 1 by s into s minus 1. ROC is real part of s greater than 0. Now if you differentiate in time domain, what happens is s is multiplied with x of s. It will become s into 1 by s into s minus 1 is 1 by s minus 1. Observe carefully. Now what happens to the ROC? Sir, can we copy this? See, the point is there are some properties that we have discussed about ROC. The properties are ROC, the most important property, or the only property that you need to keep in mind is ROC should not include poles. That is the only thing that should be there in your mind. So what are the poles here? Earlier here the poles are different. Pole distribution changed. When pole distribution changes, there is a chance that ROC might change. I'm not saying that when poles distribution changes, ROC will change compulsorily. I'm not saying that. It may change. There is a chance of change. It depends on how the poles are distributed. Okay. Right. Poles are 0 and 1. Whereas the poles here are only 1. There is no 0 pole. There is no 0 pole. Okay. Okay, wonderful. My mistake here. It should not be real part of s greater than 0. My mistake. There is a small mistake I've made in framing the question. Let's make it s plus 1. Let us make it s plus 1. Otherwise, I will not be able to convey what I have to convey. Okay. So the poles here are 0 and minus 1. If it is s minus 1, the ROC will not be a real part of s greater than 0, because real part of s greater than 0, if it is s minus 1, 1 will be part of this ROC, which is not correct. Okay. So that's why I've taken s plus 1. S plus 1. So the poles are 0 and minus 1. The poles here are no 0, only minus 1 is the pole. Okay. Now, we know from the ROC, we know that it is greater than 0 means it should be a right-sided signal. If it is right-sided signal, ROC should be right-sided. Right? So, for both poles, there are 2 poles here, both poles correspond to right-sided signals. Then only the ROC will be right-sided. Okay. Right. Now, here there is only 1 pole, and we know that this is right-sided signal. For right-sided signal, ROC will be right side of the pole. Only 1 pole. So the ROC should be real part of s greater than a real part of the pole. What is the pole? Minus 1. The ROC has changed. So does that mean that ROC always changes when you apply differentiation property in time? No. I've taken a special case where it changes. And when does it change? Because of multiplication with s, what happens is, if there is a pole at 0. See this one? Here there is a pole at 0 that got cancelled. That got cancelled. Because of that, pole distribution changed. Because of the pole distribution changed, when the pole distribution changes, then also we can't say 100% the ROC will change. We can't say that. Sometimes it changes, sometimes it will not change. Okay, right. I'll talk about other cases now. Same question. This is first one. Same question. Let's replace the data. Second question is x of s is equal to 1 by s plus 2 into s plus 3. So the ROC is real part of s greater than minus 2 minus 3. It should be minus 2. Okay. So now see this one. For this one, if you apply this property, if you multiply with s, because of that, is there any change in poles? No change in poles. If you apply this property, same property, s is multiplied with this one. No change in poles here. After multiplication with s also, zeros have changed, but poles have not changed. If poles have not changed, whenever pole distribution does not change, ROC will not change for sure. When pole distribution does not change, ROC will not change. When pole distribution changes because of applying some property, when pole distribution changes, ROC may change or may not change. In some cases it will change, in some cases it will not change. How to identify that? Find the Laplace transform, then you can easily figure out. See here, what we have done. First we have found the Laplace transform after applying the property. By looking at that, by understanding what kind of signal it is right-sided signal or left-sided signal, based on that, we have found the ROC of this one. Okay, it's easy. So don't worry about, sir, if that special case comes, how do I analyze? Just the same way you analyze all the problems. It is difficult to generalize it here. I can't write a statement. It's difficult to write a statement here which will exclude those cases. Okay, which will include those cases or exclude those cases. Writing a statement for those cases is difficult now. Okay, because there are very few cases. Fine. So in this example, there is no change in ROC after applying time shifting property also. No change in ROC. Like that, I can take 100 examples where there is no change in ROC. I'll take one more example. X of s is equal to 1 by, see here, there is nothing to cancel. When you multiply with s, when you do differentiation property, there is multiplication with s. If there is an s in the denominator already, that will get cancelled. But there is no s in the denominator here to get cancelled. Correct? Now I'll take one more example where they'll get there will be a cancellation. The previous example. There are poles at 0 and 1. If it is right-sided signal, ROC will be real part of is greater than the rightmost pole, which is 1. Okay, when there are multiple poles, how to understand the ROC? I have not discussed that, which will come under linearity property. I'll talk about it in the next slide. Okay, after this slide, I'll talk about linearity property. I'll take some cases where there are multiple poles. When there are multiple poles, how to recognize the ROC? We'll talk about that. Okay, so real part of is greater than 1. Now, for this one, if you apply this, so d by dt of x of t has a Laplace transform of s into this is 1 by s minus 1. What is ROC? Or is only one pole. For this one, ROC is real part of is greater than 1 only. See this one, ROC has not changed. Though the pole distribution changed, ROC did not change here. Here pole distribution changed and ROC changed here. So the point I want to convey is when the pole distribution changes, ROC may change or may not change. How to find it? Just find the Laplace transform, apply the property, find the Laplace transform, then you will understand it. There is nothing to by heart here. We don't need to by heart anything here. Okay? I hope you are getting it. Any confusion? After the session, take that problem, try to analyze it on your own, you'll get it. If still there is a question, I'm there in my Telegram group. I can help you there. You can post your doubt. Okay? For after session doubts. If you are having a doubt now, you can ask me now itself. Fine? Can I move ahead? I hope you've understood the point I wanted to convey here. For any property, some properties will change the pole distribution. Some properties will not change the pole distribution. The properties which can change the pole distribution, when those properties are applied, ROC might change sometimes, it might not change sometimes. Some properties will not change the pole distribution. See this one, this property will increase the number of poles at the same location, but the poles, whatever is the location of the poles, that will not change. So the pole's location will not change because of multiplication with T property or differentiation in S property. Okay, when you apply this property, location of poles is not changing and hence ROC will not change. Whereas here, we are multiplying with s. If you are multiplying with s, there is a chance that this might cancel a pole at s equal to 0. See this one? This might cancel a pole at s equal to 0, something like this. If it cancels the pole distribution changes. Even if the pole distribution changes, it is not going to guarantee that ROC will change. Sometimes it will change, sometimes it will not change. How to identify that? Find the Laplace transform, then you can clearly understand if the ROC will change or not. See here, we found the Laplace transform and then we figured out how to understand the ROC. ROC is simply, the simple fund of ROC is ROC should not include poles. Okay, right. Very good. Right. So I'll quickly discuss few important things here regarding linearity property. Let's apply linearity property. We have discussed linearity property previously also. So because I want to convey certain ROC stuff when there are multiple poles, how to find the ROC. That point I want to talk about here. So linearity property, I'll quickly revise in a minute and then I'll discuss some interesting things which you have to understand very clearly. Multiple pole scenarios, I'm going to talk about that. So A into x1 of t plus b into x2 of t. Laplace transform is A into x1 of s plus b into x2 of s. That is the Laplace transform. And ROC is, if the ROC of x1 of s is R1 and the ROC of x2 of s is R2, ROC of this total function is R1 intersection R2. When linearity property is applied, when there is a plus sign, when two signals are added or subtracted, the ROC of this total signal, ROC of Laplace transform of this total signal, or ROC of this Laplace transform is intersection of the two ROCs. Intersection of the ROCs of the two Laplace transforms. Should linearity property be applied to only two signals or multiple signals? Yes, it can be applied to any number of signals, but they should be in linear form. They should be connected in linear form. Linear form means they can be multiplied with constants, they can be added or subtracted. Other than these things, multiplication with constants, addition or subtraction, apart from this, any other operation that does not come under linearity property. Okay, so we have to deal with that kind of operations differently. Right now, you have to carefully understand now. So I'm going to discuss some interesting questions. If you carefully observe, then I can discuss it a little faster. Otherwise, it will take more. So if once we can complete this part quickly, we can move on to the today's topic, differentiation and all that. We can do some wonderful questions based on that. Right. E power 2t into u of t plus e power 3t into u of t. Laplace transform. How about the Laplace transform? When somebody asks you, when you are having multiple signals in linear form and they're asking you to find the Laplace transform, if I am doing the question, what I will do is, I will not find the Laplace transform first. What I'll do is, I'll find the ROCs first. Can you tell me the ROCs here? There is only one pole here, which is 2. In this signal, there is another pole, which is 3. I hope you are able to observe the poles here. Pole is 2 here, pole is 3 here. ROC of this signal. Since there is u of t, whenever there is u of t, it is a right-sided signal. For right-sided signals, ROC will be right-sided only. So ROC will be real part of S greater than real part of the pole. Pole is real, so real part of S greater than real part of the pole is 2. How about the ROC of this one? Because there is u of t, ROC will be real part of S greater than the pole, greater than real part of the pole. If there is u of minus t, ROC will be, there will be a less than sign here. ROC will be real part of S less than the pole, less than real part of the pole. So real part of S, since there is u of t, ROC will be real part of S greater than real part of the pole, which is 3. Okay. Now, before finding Laplace transform, I want to find the common ROC. What is ROC of this entire signal? It is intersection of these two ROCs. Intersection of these two ROCs. So what is the common values between these two, intersection. So this indicates values from 2 to infinity, 2 to infinity, and this indicates values from 3 to infinity. What are the common values? So 3 to infinity values, they exist in both of them. 2 to infinity, these values does not exist in them, because 2 to infinity, 2 to 3 values, 2 to 2, 2 to 3, 2, 2.1, 2.2, 2.3, like that 2 to 3, there are infinite values that are not present in this. Okay, the intersection ROC is not this one, but this one. So the ROC is real part of S greater than 3, means 3 to infinity values are present in both of them. So this Laplace transform of this one exists only for these values. Laplace transform of this one exists only for these values. But both the Laplace transforms are valid for these values, the common values. Okay, right. Now once we find the ROC, if I am doing the question, that this is how I do. First I will find the ROC, then only I will find the Laplace transform, because Laplace transform is the easiest part. Finding the ROC is the tricky part. So it is 1 by S minus 2 plus 1 by S minus 3. That's it. Finding the ROC is the most important thing. Right. Like this, I'll ask you one more question. E power minus 4t into u of t plus e power 6t into u of t plus e power minus 10t understand carefully. I'm going to convey an important point here. We'll generalize a few things here. I want you to find the Laplace transform of this one. So the poles are here. For first signal is e power minus 4t into u of t. There is a pole here minus 4. For this one the pole is 6. For this one the pole is minus 10. There are 3 poles here. What is ROC for the first one? Sigma greater than minus 4. For the second one, it is sigma greater than 6. For the third one, ROC is sigma greater than minus 10. What is the intersection of all of them? That would be the ROC of the entire signal. Intersection of all these 3 ROCs will be the ROC of the Laplace transform of this total signal. What is the intersection? Sigma greater than, which pole is deciding the ROC? Can you tell me? The values here are minus 4 to infinity. The values here are 6 to infinity. The values here are minus 10 to infinity. Okay. So what is the common ROC? Common ROC is 6 to infinity, correct? 6 to infinity values are present in this, present in this, present in this. So finally, I'm trying to generalize something here. Which pole, when you're taking only right-sided signals, when you're taking combination of right-sided signals, or when you're having poles which correspond to right-sided signals. See this one, this pole, this pole, this pole. All these 3 poles correspond to right-sided signals because u of t is multiplied with those exponential signals. So 3 poles correspond to right-sided signals. Among these 3 poles, which pole is deciding the ROC? Anyone? Here we know it is 6 to infinity. Sigma greater than 6 is the answer. Sigma greater than 6 is the answer. Or can we write it in a more generalized way? Sigma greater than maximum of all the poles. What is the maximum pole? What is the maximum pole? Or highest pole? Or maximum of a real part of the poles? All right-sided poles. Right-sided pole means the pole corresponding to right-sided signals. See here I have given you some beautiful point here. I don't know how much it is clear for you, but I'll explain it. See here there are 3 poles, minus 4, 6 and minus 10. Among these 3 poles, which is the highest pole, or the pole with the highest value? 6 is the highest value. The pole with highest value is 6. That is deciding the ROC. Is that the case for left-sided signals also, or signals with u of minus t? No, that is different case. I'm talking about only right-sided signals or signals with u of t. If you're having combination of signals with u of t, or you're having only right-sided signals, combination of right-sided signals like this, then which is the pole that is deciding the ROC? The rightmost pole. Sigma greater than, it's more easy to say like this. Instead of like this, I'll say it as sigma greater than a real part of rightmost pole. This is more easy to understand. Rightmost pole. If this is not clear, try to understand this one. In S-plane, if you plot this pole, -4 you can plot, 6 you can plot, -10 you can plot. Among these three poles, which will be the rightmost? Obviously 6 will be the rightmost. That rightmost pole is the deciding factor in ROC, final ROC. And in that rightmost pole also, only the real part is important for us. Here the poles, all the poles are real only. Okay, here all the poles are real, but if you are having imaginary poles, I mean complex poles also, then also you can apply this. Among the rightmost poles, rightmost pole will decide the ROC. In that rightmost pole also, only the real part is important when you are calculating ROC. Okay, now let's find the Laplace transform. It is 1 by s plus 4 plus 1 by s minus 6 plus 1 by s plus 10. ROC is finally, we found the ROC first. It is sigma greater than rightmost pole, real part of rightmost pole. Now I'll give you another question so that it will be more comfortable for you now. I'll take more poles also. Okay, minus 2t plus e power minus 6t plus e power 10t plus e power 7t plus e power 0.5t into u of t. See this one? How many poles are there here? We want to find the Laplace transform of this one. There are, I have given you 5 poles. 1, 2, 3, 4, 5. 5 exponential signals are there. All of them are right-sided signals. Okay. See, if you don't remember that point that I have discussed here, that's fine. That's completely fine. Go with the basics. So how did we get this point? We have observed this point from the basic analysis only now. Okay, even if you don't remember any point, that's fine. Go with the basics. Find the ROC for this. Find the ROC for this. Find the ROC for this. Take the intersection of them. As simple as that. We are not doing anything more than that. Based on the basics only, we are making some observations. If we can remember those observations, that is fine. If you don't remember, that is fine. Because another half minute it will take to analyze. Okay. With this problem, I think you should get clarity. So we are taking combination of right-sided signals. Now, among the right-sided signals, which pole is important? When you're taking combination of right-sided signals, all right-sided signals combined, or let me say like this. Among the right-sided signals, observe carefully, among the right-sided signals, which signal or which signals pole decide pole, it's not poles, it's pole, only pole, one pole, decides the ROC. Can anyone answer this? I told this answer in the previous slide also. Among right-sided signals, see these are 5 right-sided signals. Among the right-sided signals, which signal's pole decides the ROC? Anyone? Anyone? The poles here are, let me write the poles, -2, -6, 10, 7 and 0.5. There are 5 poles. Among the right-sided signals, which pole is important in deciding the final ROC? As I told you earlier, sigma greater than real part of rightmost pole. The ROC is decided by the rightmost pole. When you have a combination of right-sided signals, the ROC is decided by the rightmost pole. Which is the rightmost pole here? If you plot these on a graph, so -2 is somewhere here, -6 is somewhere here, 7 is somewhere here, 10 is somewhere here, 0.5 is somewhere here. This is 0.5, this is 7 and 10. Okay, so among these poles, which decides the final ROC? This rightmost pole decides the ROC, because if I plot the ROC for this signal, all these signals, and if you take the intersection of all of them, only the ROC of 10, ROC correspond to this pole, the rightmost pole, is deciding the overall ROC. So which signal's pole decides the ROC? Signal with the rightmost pole Signal with rightmost pole decides the ROC. And what is the ROC? We have just now understood who decides the ROC. Signal with rightmost pole. Which is the signal with rightmost pole? This is the signal with rightmost pole. This decides the final ROC. But all the signals decide the Laplace transform. But this is the signal which will decide the final ROC. And what is ROC? ROC is sigma greater than, we can say rightmost pole if the pole is real, but if you want generalized, sigma greater than a real part of rightmost pole. If you have only right-sided signals, or when you are in a signal, if you combine right-sided signals or those right-sided signals together, you can find the ROC in this way. If you don't remember this, that's fine. After a few months, you might forget this. That's fine. Go with the basics. Find the Laplace transform of this one and ROC. Find the ROC of this one and ROC of this one. Find the ROC of this one. And take the intersection of all of them. Then you'll get the overall ROC. But if you can understand this point, digest this point, then when you look at this kind of signal, just like that you can find the ROC. Without taking much time. With a few seconds you can tell the ROC. If you have understood or digested this point clearly. Okay, right. Now let us discuss one more case. How about the Laplace transform of this? In the previous slide, I did not find the Laplace transform, but it's very easy. It is 1 by s plus 2, 1 by s plus 6, 1 by s minus 10, 1 by s minus 7, 1 by s minus 0.5. ROC is sigma greater than 10. Right. How about left-sided signals? For left-sided signals, I'm going with the basics. Basics means this is how you have to analyze. If you don't remember the observations, go with the basics. Going with basic means the way I'm going right now. So for this signal, what is ROC? Since it is left-sided signal, ROC will be left-sided ROC, which is real part of S less than a real part of the pole. The pole here is minus 5. ROC for this signal is real part of S less than a real part of the pole. And this is also left-sided signal. ROC will be real part of S less than real part of the pole. The pole is minus 4. Real part of the pole is also minus 4. And for these two signals together, what is ROC? Take the intersection of them. If you take intersection, what are the values here? Minus infinity to minus 5 are the values that we are talking about here. And what are the values that we are talking about here? Minus infinity is the last value. Minus 4 is the value. That is the range. This range is the ROC for this signal. This range is the ROC for this signal. What is the intersection of them? Minus infinity to minus 5, minus infinity to minus 4. The common values are minus infinity to minus 5. Because minus 5 to 4, those values are not present here, but they are present here. We want only intersection values or common values. So the ROC is a real part of S. This values I'm writing, real part of S less than minus 5. So finally, the Laplace transform is 1 by s plus 5 plus 1 by s plus 4. Before finding this, we have to find the ROC. We have done that. We have first found the ROC. ROC is the most important part. Right. So what is the final ROC? Real part of s less than minus 5. Now tell me, which pole is deciding the ROC? Among the left-sided signals or signals with u of minus t. Among the left-sided signals, which signal decides the ROC, or which signal's pole decides the ROC? Anyone? Can anyone answer me this? See this one? Minus 5, minus 4. If you plot the poles, minus 5 is here, minus 4 is here. So if you plot the ROC for the first one, left side of minus 5 will be the ROC for the first signal. Left side of minus 4 will be the ROC for the second signal. Combined ROC will be only left side of minus 5. So among these two poles, which pole is deciding the ROC? See this one, finally we are having left-sided ROC. Left-sided ROC, left-sided ROC, when you take intersection, whichever ROC is the leftmost, that way it is deciding the final ROC. Leftmost ROC is decided by leftmost pole. Okay. So which signal is deciding the ROC? Signal with leftmost pole. Signal with leftmost pole is deciding the ROC. And what exactly is that ROC? Signal with leftmost pole is deciding the ROC, and the ROC is sigma. Because you are talking about left-sided signals, ROC will be sigma less than real part of the pole. Which pole is that? Real part of leftmost pole. Real part of leftmost pole. So the point here is, for right-sided signals, ROC is sigma greater than rightmost pole, real part of rightmost pole. For left-sided signals, it is sigma less than a real part of leftmost pole. I hope this point is clear. For right-sided signals and left-sided signals, we have discussed it. Now, what if there is a combination of it? What if there is a combination of it? We talk about it. Let's talk about combination of it. See here, in this signal, we are having combination of right-sided signals as well as left-sided signals. Now, what we will do is, whatever we know till now, let's apply that. So, let's find the ROC of these two things. Or we can go with the basics also, right? We can go with the basics also. But whatever points we have learned in this session, let's apply those points. So, what is ROC of this combined thing? When you are having combination of right-sided signals, ROC is, for these two signals together, ROC is sigma greater than a real part of rightmost pole. What is the rightmost pole here? Minus 2 and 4. Among these minus 2 and 4, which is the rightmost? 4 is rightmost. So sigma greater than 4 is the ROC. What is the ROC of these left-sided signals together? There are two left-sided signals. For left-sided signals, ROC is sigma less than real part of leftmost pole. For left-sided signals, leftmost pole is important. For right-sided signals, rightmost pole is important. Rightmost pole decides the ROC in right-sided signals. Leftmost pole decides the ROC in left-sided signals. What is the leftmost pole here? Among 7 and 10, 7 is the leftmost pole. So sigma less than 7 is the ROC. Sir, if I don't get the idea, okay, let's go with the basics. Going with the basics means, see this one. What is ROC for this? Sigma greater than 4 is the ROC. What is ROC for this? Sigma greater than minus 2. What is the intersection of these two? That is what we get. Intersection of these two, that is the answer. And how about the ROC of this one? Sigma less than 7. The ROC of this one is sigma less than 10. If you take the intersection of these two, this is the answer that we are going to get. From the basics only, we have observed these things. For right-sided signals, ROC is sigma greater than real part of rightmost pole. For left-sided signals, ROC is decided by the leftmost pole. These points we have observed from the basics only. If you forget the observations, go with the basics. Going with the basics might take a little bit, another half minute or so, but we are going to get the answer ultimately. If you have that confidence that using basics, I am having good basics, with that basics I can find any answer. If you have that confidence, you can do any problem. Okay, so don't fear that you might forget the observations. If you use those observations too many times, you will remember them anyway. You don't need to put any extra effort. When you do multiple problems, you're going to apply these things, right? You're going to apply these observations, then definitely you're going to remember them. You'll not forget them. But if at all, if you forget also, have confidence that I know the basics. I know the basic procedure. I can apply that and I can find the answers. Right? Very nice. Now, let's combine these two. So, what is the intersection of these two? Finally, basics only. Basics is what is important. We are going to take the intersection of ROCs of all the 4 signals. What is the intersection of all of these 4? Or intersection of these 2 or all these 4? Both are same. So, intersection of these 2 we have done. Intersection of these 2 we have done. Now, let us intersect both of them. So, what are the values that we are talking about here? 4 to infinity is the values that we are talking about here. What are the values that we are talking about here? Minus infinity to 7. So, can you tell me the common values? 4 to infinity, minus infinity to 7. I think there are common values. It is 4 to 7 are the common values, correct? 4 to 7. 4 to 7, that is there in this. 4 to 7 is there in this also. 4 to 7 values, they're common between these two ROCs. So finally the ROC is, you can find the Laplace transform as 1 by s minus 4 plus 1 by s plus 2, okay, and minus 1 by s minus 7 plus minus 1 by s minus 10, and the ROC is sigma between 4 to 7, 4 less than, sigma less than 7. Laplace transform we know how to find the Laplace transform of individual signals. Most important part is ROC, that is what we found out. Okay. First analyze the right-sided signals, find the ROC. Analyze the left-sided signals, find the ROC of left-sided signals and combine the ROC. Okay. Right. One more question I'll ask you. So I've taken a combination of left-sided and right-sided signals. I just want to convey an important point here. So that's why I've taken this question. Now observe and tell me. Find the ROC and along with Laplace transform. So this one we know ROC is right-sided signal, ROC is sigma greater than real part of the pole, which is 4. ROC for the left-sided signal is sigma less than a real part of the pole, which is minus 5. What is the intersection of these two values? Intersection of these two values, we are talking about 4 to infinity values here. We are talking about minus 5 to minus infinity to minus 5 here. Is there any intersection? Anyone? Intersection is null. There are no common values here. There are no common values. Which means the Laplace transform of this one exists for sigma greater than 4 value. The Laplace transform of this one exists from 4 to infinity. And the Laplace transform of this one exists from minus infinity to minus 5. But there are no common values for which both the Laplace transform exists. There are no sigma values for which Laplace transform of both the signals exists. Right? So, since there are no values of sigma or there are no values of s for which Laplace transform exists, we say that does not exist. Laplace transform does not exist for this signal. Or you can say it is not defined for this signal. When there is no common ROC, do you know why I am telling you first find the ROC? For this reason. Because for some signals, when you take combination of right-sided and left-sided signals, sometimes the ROC will exist, common ROC will exist and Laplace transform will exist, but sometimes it may not exist. Sometimes it may not exist. Okay, just find the ROCs and take the intersection. I can tell you an observation here, but I better not tell it because it's difficult to remember as an observation, or it makes things complicated. So it's better when you're having combination of right-sided and left-sided signals, find the ROC of right-sided signals, ROC of left-sided signals, and then take the intersection. It's easy. If the intersection is there, then only the Laplace transform exists for certain values of sigma. If the intersection is not there, if the intersection is null, then the Laplace transform does not exist. Because the common ROC is null. There is no common ROC. Okay? I hope it is clear till this point. So I wanted to tell you how to find the ROC when multiple poles are involved. Okay. So here in the last 3 slides, I have discussed about multiple poles. If the multiple poles correspond to right-sided signals, ROC is decided by the rightmost pole. If multiple poles correspond to left-sided signals, ROC is decided by the leftmost pole of left-sided signals. When you're having combination of right-sided signals and left-sided signals, okay, when you're having combination of right-sided signals and left-sided signals, among the right-sided signals, rightmost pole is important. Among the left-sided signals, leftmost pole is important. And those two poles, leftmost pole of left-sided signals, rightmost pole of right-sided signals, they are going to decide the ROC. See this one? 4 is the pole corresponding to right-sided signals. 7 is the pole corresponding to left-sided signals. Those two poles will decide the ROC provided there is a common ROC. If there is no common ROC, the Laplace transform will not exist. Okay, I hope it is clear till this point. If there is no common ROC, Laplace transform does not exist. Okay, I'll ask you one more question here. How about constants Laplace transform? I'm talking about bilateral Laplace transform. Mind this, bilateral Laplace transform. Unilateral Laplace transform, you might have learned it for one in mathematics. That's not same as this. What is a bilateral Laplace transform of 1? Can we write 1 as whatever signal is given, try to express it in terms of known signals, whatever signals you know already. So we know u of t, we can write it, plus u of minus t also we know the Laplace transform of both of them. We can write one as u of t plus u of minus t. So how about the bilateral Laplace transform? In bilateral Laplace transform, ROC is very important. What is the ROC of this signal? U of t, the pole is e power 0 into t, we can write it as e power 0 into t. Pole here is 0, ROC is sigma greater than 0. And for this signal also pole is 0, ROC is sigma less than 0. What is the intersection of the ROCs? Null. There is no intersection. So for constant signal, bilateral Laplace transform does not exist. Mind this. But unilateral Laplace transform exists. Okay. For one, if you talk about unilateral Laplace transform, you are trying to integrate this only from 0 to infinity, which means you are treating it like u of t. So that's why the Laplace transform will be 1 by s. When you are finding unilateral Laplace transform, you are integrating it from 0 to infinity. 1 into e power minus st into dt, which is same as integration from minus infinity to plus infinity, u of t into e power minus st. See this one? These two are same, na? So bilateral Laplace transform of u of t or unilateral Laplace transform of 1, both are same, right? You might have learned this one in mathematics. Laplace transform of 1 is 1 by s. That is unilateral Laplace transform. So unilateral Laplace transform, we also call it as one-sided Laplace transform because we deal with this Laplace transform only for positive time. Whereas bilateral Laplace transform, the formula is from minus infinity to plus infinity, which means we deal for positive time as well as negative time. So that's why we call it as two-sided Laplace transform. We call it as two-sided Laplace transform. Okay. Right, mind this. So there are some signals which you feel like you know the Laplace transform of, but the Laplace transform for those signals does not exist. Cos AT. How about the Laplace transform of this one? Don't say s by s square plus a square. I am talking about BLT, bilateral Laplace transform. If you remember, we have found the Laplace transform of cos AT into u of t, right? So I'm writing cos AT as cos AT into 1. 1 I'm writing it as u of t plus u of minus t. Okay, so first part is cos AT into u of t plus cos AT into u of minus t. Don't find the Laplace transform first find the ROC. What is the ROC of this signal? This is right-sided signal. ROC is sigma greater than the real part of the pole. The poles here are JA and minus JA. Real part of the pole is 0. And what is the ROC for this one? Sigma less than real part of the pole, which is 0. Sigma less than 0. The intersection ROC is null. So that's why Laplace transform of cos AT, bilateral Laplace transform of cos AT or sin AT does not exist. Mind this, does not exist. Okay. So let me generalize this. Okay. Let me generalize this. Sir, is there any way to remember for what signals it does not exist? Yes, I'll tell you. Power signals. So this is a power signal. This is also a power signal. And the power signals and neither energy nor power signals. This is the generalization I can make. Power signals and neither energy nor power signals which exist from minus infinity to plus infinity. Power signals and neither energy nor power signals which exist from minus infinity to plus infinity. For those signals, Laplace transform for power signals and neither energy nor power signals which exist from minus infinity to plus infinity, Laplace transform does not exist. See this one? This is a power signal which exists from minus infinity to plus infinity. But u of t is power signal, but it exists only from 0 to infinity. This does not exist from minus infinity to plus infinity. See this one? Cos AT into u of t. We have Laplace transform for this because it exists only for positive time. But whereas only cos AT, it exists for overall time, all time, from minus infinity to plus infinity. Power signals which exist for minus infinity to plus infinity, for those signals, and neither energy nor power signals which exist from minus infinity to plus infinity, for those signals Laplace transform does not exist. Right, I'll take one more example of neither energy nor power signals. E power 2 mod t. See this one? For this one, how about the Laplace transform? Let's find it. E power 2 mod t, I'll write it as e power 2t into u of t. For positive time, you can write like this. For negative time, you can express it as e power minus 2t into u of minus t. So ROC for this one is sigma greater than 2, and the ROC for this one is sigma less than minus 2. And the intersection is null. So Laplace transform of this is an exponential signal. It is an exponentially increasing signal both sides. And exponentially increasing signals are neither energy nor power. But this exponential signal, this is a neither energy nor power signal. It exists from minus infinity to plus infinity. It exists for all time. Hence, its Laplace transform does not exist because there is no value of s or sigma for which the Laplace transform exists for these two signals together. There is no value of sigma for which the ROC condition is satisfied. I hope you are following. I've made some very important point here, very interesting point here. So I've told you in this slide, I've told you for what kind of signals Laplace transform, bilateral Laplace transform does not exist. Don't get confused with what you learn in mathematics. What we learn in mathematics is unilateral Laplace transform. Unilateral Laplace transform exists for this one, whatever signals I told you that it does not exist here, but for all of them, unilateral Laplace transform exists. Okay, only bilateral Laplace transform does not exist. Okay, right. So let's quickly come back to our differentiation property, whatever we have learned here. Differentiation property in time. If x of t has a Laplace transform of x of s, then if you differentiate in time, then Laplace transform becomes s into x of s. ROC is r, if the ROC is r here, and I'll write it as r only, but I told you some special case. There are few very special cases where ROC might change. Most of the cases ROC does not change. Okay. Sir, in a problem, will I be able to find out if the ROC changes or not? Yes, you will be able to find out. Apply the differentiation property, find the Laplace transform. Okay, understand the poles, and from the poles, you know how to figure out the ROC. In the previous slides, we have discussed using linearity property. If there are multiple poles, right-sided poles, left-sided poles, or combination of them, how to find the ROC we have discussed. Okay, because of once you find the Laplace transform, from that you figure out the ROC. When you're applying properties, find the Laplace transform first and then figure out the ROC. Okay, but when you're applying linearity property, when you're having combination of signals, first find the ROC and then find the Laplace transform. Because sometimes there might be no common ROC, which means Laplace transform may not exist. When you are having that kind of scenario, see this one, I'll show you. So when you're having this kind of scenario, if you write it as 1 by s minus 4 plus 1 by s plus 5, and finally, once you figure out that there is no common ROC, you have to cancel all of that, right? So that's why it's better to find the ROC first and then write the Laplace transform. But there is nothing wrong in first finding the Laplace transforms and then finding the ROC. There is nothing wrong in that. But if I'm doing it, I would do it like this. Okay. So right, I'm going to extend this property. So if you differentiate it n times, so we can do differentiation multiple times also, okay? If you differentiate n times, then s is also multiplied n times. So ROC will be not changing most of the times. So differentiation property can be applied any number of times. The number of times that you apply the differentiation, that number of times s is multiplied here. So that is the differentiation property in time. How about differentiation property in s domain? Let's quickly discuss this also. We have discussed this previously in the previous slides also, but I'm just gonna recollect it once and I'm gonna add something to it. You know the Laplace transform of a signal. Now if t is multiplied with the signal in time domain, we can also call this property as multiplication with t property. Multiplication with t property. This property is there in Fourier transforms also. Similar property is there in Fourier transform also. If you multiply with t in time domain, in Laplace, what happens is differentiation happens, but there is an extra minus. Will the ROC change? No, no change in ROC will happen. Similarly, if you multiply with t multiple times, multiple times differentiation will happen. Multiple times minus sign will be multiplied. So minus sign will be multiplied n times because you are multiplying with t n times. And differentiation also will happen n times with respect to s because you are multiplying with t n times. And ROC does not change. Using this property, let's find some interesting Laplace transforms. U of t Laplace transform we know 1 by s. ROC is sigma greater than 0. How about R of t? R of t Laplace transform is, so R of t is nothing but what? It is t into u of t. No? So to find Laplace transform of R of t using u of t Laplace transform, we can take the help of multiplication with t property. See, if you multiply with t in time domain, what happens in Laplace? It is minus d by ds of Laplace transform of the signal for which you are multiplying with t. It is 1 by s, which is equal to minus 1 by s square into minus is 1 by s square. And there is only one pole here. There is a pole at 0, but double pole. Same pole at 0 twice. So ROC, only condition is it should not include poles. See, the pole is here. Without including this pole, how many regions can you create? Only 2 regions, right? This is first region and this is second region. If it is right side signal, the first region will be the ROC. If it is left sided signal, if it is u of minus t, then second region will be the ROC. There are only 2 possible ROCs with one pole. Okay, there is only 2 possible ROCs with one pole because only 2 regions you can create without including that ROC. Okay, so this ROC will happen if it is right sided signal. This ROC will happen if it is left sided signal. So ROC will be, there is only one pole here, but it is a double pole. So ROC which will not include that pole is, there are 2 possible ROCs. One is sigma greater than 0 and another one is sigma less than 0. The ROC which we have to consider is, because it is right sided signal, we have to consider right sided ROC, sigma greater than 0. Similarly, if you take R of minus t, you can apply time reversal property for this. S replaced with minus s. S replaced with minus s. It is 1 by s square. ROC is real part of s greater than 0 here. Here it will be real part of minus s greater than 0, which means sigma less than 0. See this one? For this one also, same pole, 0. But this is left sided signal. You are talking about left sided signal here. For left sided signal and right sided signals, ROC should not be same. The other ROC possible with the pole 0 is sigma less than 0. Okay, poles will decide the ROC. Poles along with the right sidedness or left sidedness of the signals will decide the ROC. Okay, I hope it is clear till this point. So using this property, we can find the ROC of t square into u of t also. What is the Laplace transform of t square into u of t? If you multiply with t again, so 1 by s square differentiation is minus 2 by s cube, and another minus sign the property, so it becomes 2 by s cube. So finally we can make some generalization here. T power n into u of t Laplace transform is, see this one, 1t, second t, what happened here, 2. So if you multiply with t again here, again differentiation will happen. After differentiation, what happens? It is 2 into 1 by s cube differentiation is minus 3 by s power 4, another minus sign because of the property, so it will become minus 6 by s power 4 or 3 factorial by s power 4. So t power n into u of t can be generalized as n factorial divided by s to the power of n plus 1. So this is the generalization. If you remember it, that's fine. If you don't remember it, also that is also fine. I don't suggest too many things to remember. Understand the basics. Basics you will not forget. Very good. Right. So these are the differentiation properties which you can apply to solve many questions. Right. So integration properties also I'll show you. Okay. Integration properties also I'll show you here. So this is a image I have taken from Wikipedia. See here, this property we have discussed, this property we have discussed, these two also we have discussed. So differentiation properties. So next, integration property. So if you multiply with 1 by t or divide with t in time domain, what happens is multiplication with t is doing differentiation in Laplace, right? So dividing with t, what happens it will do is, it will do integration. But mind the limits, it is from s to infinity. This property generally we don't apply. But anyway, we have to learn it, right? What happens with when you multiply with t, we know it. So what happens if you divide with t is integration. Multiplication with t is creating if differentiation, means dividing with t should do integration, but mind the limits. Limits are from s to infinity. Similarly, integration property. So this is integration property in Laplace. How about the integration property in time? So if you integrate from minus infinity to 2e, on the other side, differentiation in time domain, what is it doing in Laplace? Multiplication with this. Instead of differentiation, if you do integration, just the opposite of this is this. Dividing with s will happen. So this is the property that we mostly apply, but there is one more property also. Instead of integration from minus infinity to t, these are the limits that basically we use when we do integration. But if you take the opposite limits, the limits which are remaining from the total region from minus infinity to plus infinity, the remaining limits in this integration are t to infinity. If you take those limits, then also it is 1 by s, but the ROC will be different. So how to find the ROC? Don't worry about that. First find the Laplace transform. Once you find the Laplace transform, pole zero distribution might change. If it changes, then the ROC might change. If the pole distribution, based on the pole distribution, you can figure out the ROC. Don't remember anything of this. You don't need to remember this. You can figure it out based on the poles. Because too many things, if you remember, you might forget it. Okay. So whatever integration you do with any limits, minus infinity to t or t to infinity, don't take other limits. For other limits, that property is not defined. If you want to find other limits, you have to go with the basics. You have to use the basic Laplace transform formula and find it. But for these limits, there is a property. So integration, if it is from minus infinity to t or t to infinity, in both cases it is 1 by s. Sorry, how can it be same? It is not same. See, the ROC will change. Okay, ROC of the lower limit of the ROC will change in this case, whereas higher limit of ROC might change here. It's not exactly same. ROC change will happen in the ROC. When the limits are different, the change happens in the ROC side, not in the Laplace transform. Okay, I hope it is clear till this point. So I have revised, I have quickly talked about integration properties in today's session. We have discussed in detail about differentiation properties. Okay, so most of the time, problems are framed based on differentiation properties, these 4 properties. Very rarely we are framed questions based on integration properties. That's why I'm not able to spend time on integration properties, because there is less probability of asking questions based on integration properties. Okay, but it's better you practice at least few questions based on integration properties as well. Okay, fine then. So we'll stop at this place. So before stopping, I'll give you some homework questions as well. So these are the homework questions. You can try it after the session. And if you have not subscribed already, kindly subscribe. And if you have liked the session, press the like button. Okay, fine then. So take care. Have a good day. We'll meet again in tomorrow's session. In tomorrow's session, we'll talk about some other interesting topic based on Laplace transform itself. Okay, until then, take care and goodbye.